because laser physics is a huge and lot of time will go in understanding the laser physics, but I have a different way to understand it. Okay, there are two bands. Yesterday I have told you there is a valence band and conduction band. Whenever the electron gets the energy at valence band, it jumps to conduction band, and there is a certain life of that electron. It decided that how much energy he have absorbed. Okay, at that amount of energy, how much time he is going to survive at conduction band. Okay, after that, spending that time, it will come back to the lower state, and the energy which he has absorbed at the valence band, okay, that energy will be released out. Okay, now how you can connect the laser physics with the life? How you can connect the laser physics with the life? There is a very good connection between the life and the laser physics. Okay, and if you understand your life, then you will understand the laser. So just keep your brain open. The story is, one child takes birth. It is the same way the electron gets energy at valence band and gets into the conduction band. Fine. So that birth is related to something when the electron comes to the conduction band. Now, what I wanted to tell you is, I have told you in conduction band there is a fixed life of electron. Fine. The same way there is a fixed life of human being when it comes to when he or she takes a birth on this earth. Right? Now, there are two things happens related to death. Two chances of death. One, the person dies in between his life, 10 years, 12 years, 15 years, 25 years, 35 years, or 50 years or 55 years because of some cause. And one person who completes 100 years, he goes to bed at night and morning he goes away. No reason. The reason is only he has completed his time. Two things, got to understand? Fine. Now, tell me, if a 100-year person dies, then you would like to cry, or if a 40-year person died, then you would like to cry.
If the person dies for 40 years,
the person dies at 40 years, you will cry for him? Fine. Means, if somebody does not completed his life and went away, then the energy release would be more. Then the energy release would be more. The person died, the wife is crying like anything. The kids are crying like anything. The mother is crying like anything. Means the more release of energies. But if the person died at 100, people used to dance. People used to beat the drum.
There was baby cries, sir. Because of there is a long relation with the 100 years of.
They cry, but they have some satisfaction in their mind.
They are waiting for it.
Yeah, most of the time people are waiting for it. Yes, most of the time people are waiting for it. And the other thing is that will give another satisfaction, feeling of satisfaction that yes, he has completed his whole life. So at that time the release of energy would be very less. This is what, there are two types of emissions in life and in laser physics. There are two types of emissions: spontaneous emission and stimulated emission. Spontaneous emission and stimulated emission. Spontaneous emission is those emission in which the electron or the person completed his whole life and then he goes back from where he came. That is known as spontaneous emission, and spontaneous emission will having a lesser amount of energy release. But if the person dies with the accident, there is a cause. If the person dies with the HIV, if the person dies with the tuberculosis, there is a cause. That will make an stimulated emission, that will compel the person to go back from where he came. That is stimulated emission. And in case of stimulated emission, the release of energy would be higher. Okay. And in laser, we use stimulated emission. In lasers, we would use stimulated emission. Now, how stimulated emission works, that we have to understand. How stimulated emission works. I told you for stimulated emission, we need a cause. Okay, if the person dies at 40 years, so we will have the cause of death. Okay, but the person dies at 100 years, we don't have the cause of death. Okay, so in its stimulated is spontaneous emission the only cause that is completion of life. But in case of stimulated emission, the cause may vary. Road accident, illness, blah 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 blah. Okay. But the thing is that in stimulated emission, release of energy would be higher, and spontaneous the release of energy would be lesser. So that is the only reason we want high energy. That is why in lasers we have stimulated emission. Means we will compel the electron at conduction band to go back to the valence band before his time of completion. Okay, this is what we are doing in lasers. Okay, now this fundamental is clear? No doubt in this? Fine. What happens at laser? There is a lastic material. Lastic material is nothing but is a material which is used for production of lasers. Okay, it could be helium ion, it could be semiconductor, it could be any other gas. Okay, I will tell you what are those gases are. Okay, so we kept it at valence band first. We used to energize it by providing an voltage to that material. The material gets a voltage supply that is in form of electrical energy. We have delivered the electrical energy. The electrons at valence band absorb that energy and goes into the conduction band. Now, there are two things can happen. Now at conduction band, one thing is the electron will complete its life and go back. That is a spontaneous emission. Another thing is electron will not complete its life and will go at the valence band. That is stimulated emission. But I told you, stimulated emission requires a cause. Now, what is the cause is the jumping of electrons from valence band to conduction band in laser is known as pumping. That mechanism is known as pumping. We are pumping the electron from valence band to conduction band. That mechanism is known as pumping. Fine. Now, what is the cause actually? Cause is this room is there. Okay. This room is having a capacity of 50 people. Fine. Now, we are making the people enter into this room beyond 50. Fine. Let's say we have accommodated 100 people. Now, still, we are putting more people. What will happen? Huh? It will become congested. The energy level will increase here in this room. Okay. Energy level will increase, but I am still not stopping. I am still putting more people. Then what will happen? One exit will be created. That this point would be acting as an entrance point. There is no other exit. Then one exit will be created by its own. Fine. Now that exit is created. Fine. Now the rate at which the people are entering at this gate would be equal to the rate at which the people are exiting out. Clear? This is what we are doing in lasers. We have fixed that rate. How many of electron will jump in 1 second will jump from valence band to conduction band. Okay. We have filled the whole conduction band first. Then we have fixed the rate at which rate the electron will jump from valence band to conduction band. The rate at which the electron will jump from valence band to conduction band, the rate is same. The electron will come from conduction band to valence band back. And while they are coming valence band to conduction band to valence band, basically I am using a force. I am just forcefully forcing them to go down because of the population, because of the increasing population. This process in laser is known as population inversion. This process in laser known as population inversion. One process is pumping valence band to conduction band. That is the process of pumping. The forcing, making the population number of electrons increase at the conduction band and making the electrons to go down at valence band before its lifetime. Okay, that process is known as population inversion. And population inversion means increase in population. That's it.
There is a emission means valence band to conduction band.
No, not emission. Pumping. Pumping means jumping of electron from valence band to conduction band. Okay.
Liberation of the laser.
No. Yes. I will tell you where the laser will generate now. I will tell you. I'm just in the process here. That process is known as, so far I have told you two processes. One is pumping, another is population inversion. Both the processes are clear to you? Both the processes clear to you? Population and pumping?
Yes, sir.
Okay, fine. Spontaneous and stimulated is clear?
Yes, sir.
Fine. Now the electrons are coming from conduction band to valence band because of population inversion, because of the increase in population at the conduction band. The reason is same. We have got the cause of stimulated emission now. As I told you, for stimulated emission we should have a cause. So we got the cause. We have the cause. Clear with this? Everybody is agree with this point? Fine. Now we have a cause. Now, what will happen if the person dies before completing his life? I have told you there would be a more release of energy. There would be more release of energy, and in laser also we want more energy. Okay. So if the electron will come before completing his lifetime from conduction band to valence band, then there will be a more release of energies. And you know the rate is fixed. The rate is fixed means the rate is proportional to the entry with exit. The rate is same. Okay, means it will become a train mechanism. You know, let's say this is my conduction band. This is entry point. This is exit point. This distance is fixed. The rate from by which the electrons are coming at conduction band, that rate is fixed. Fine. Let's say it's a train mechanism. Why? This first electron enters here, as second electron will come, this will shift here, this will shift here, this will shift here, this will shift here, and this will shift here. This is the last point. It reaches one exit point, it will go down. Fine? There is a proportionality. There is a proportionality. So means the time taken for entry at the conduction band and time taken for the exit for every electron, that will be same, because the rate of pumping is constant. Right? So it means that all the electron will spend a fixed time. Means we have decided that electron supposed to spend 1 minute at conduction band, then all the electron will spend only 1 minute only. Fine. For example, the fixed lifetime of electron at conduction band is 3 minutes, let's say. Okay. But because of population inversion, we did what? We made it 1 minute. So it is not possible for any electron to spend 1 minute, 1 second also in the conduction band because of the train mechanism. It's a train mechanism, the engine and the last coach. This way it goes up. So what will happen when I told you the energy which has been absorbed at lower state, the energy which has been absorbed at lower state, that energy could be released while coming back from conduction band to valence band. But the law says energy cannot be created nor be destroyed. Energy cannot be created nor be destroyed, but it can change its form. So the electron which have taken electrical energy, that electron at that time when coming back from conduction band to valence band, it will give you the light energy. It will give you the release of light energy. It has changes the form of energy. They have not created any energy, they have changed the form of energy, and the order of energy and the form of energy, these two things can be changed. Order and form of energy can be changed. So form is electrical to light. Fine. The order means the frequency and wavelength can be changed. So the frequency and wavelength of that emission would be changed. Okay. Now the thing is that as I have told you, all the electron will consume the same amount of voltage at the valence band. All electron will spend the same amount of time at conduction band. Okay, it means that all electrons which are emitting while coming back to conduction to valence band, that will emit in same amount of energy, in same form, in same order. Okay, getting my point? Means that, for example, we have fixed that all the electron will emit at 763 nanometer, that is in wavelength, at 25 kilohertz frequency. So all, next example, Okay, so all the electron will emit at 763 nanometer and 25 kilohertz of frequency. All the electron. This is what the lasers makes. This is the only thing which makes the laser travel into a line, which is known as monochromatic. This is what the laser monochromatic. This word is known as monochromatic. Means a single color. This makes laser which is being emitted through the laser tube will be single color, monochromatic. Okay. The another thing is directional. In the order of the energy is same, the level of the energy is same, the form of the energy is same. Okay. It means it will be in a particular direction. Okay. So this makes the laser two directional, monochromatic, and a constant energy level. Okay. But in other of the lightning sources, other of the light which we used to produce from the bulb, let's say, in bulb we don't have stimulated emission. We have a spontaneous emission over there in the bulb. In the bulb we have spontaneous emission. We don't have stimulated one. In the bulb we don't have stimulated one. We have spontaneous. Okay, that is why the bulb light does not go into single direction. It goes like this. Because all the electrons emit different level of energy, different level of frequency, different color of light. So bulb is having all the 7 colors in it. Bulb is having all the 7 colors in it, but it seems yellow to me because I am looking at the light of the bulb with bare eyes. If I take a prism in front of the bulb, then the prism will divide all the 7 colors from the light of the bulb. But if you keep a prism in front of laser, after crossing the prism, then to the color of the light will be same. That is, red means red, yellow means yellow, blue means blue. Okay, clear this factor? Fine. Now the question arises, sometimes people say laser is visible or not. Laser is visible or not. First of all, the production of laser is clear to all. How we are producing? Pumping, then operation
and vibration spontaneous.
Stimulated emission. Okay, so all the things, and this amplification means what we are doing is from valence band to conduction band shift is there, that is amplification. Stimulated emission is clear to you. Radiation means the energy which the electrons are emitting, that makes a radiation. And what is the definition of radiation? The energy is in motion. Energy is in motion, that is known as radiation. Clear each and every word? And in form of light. Clear? Okay, fine. Now, what I want to tell you, this is about the laser physics. This is how the physics goes on. And it took 2 years for me to understand this whole phenomena which I am making in just in 2 minutes. Okay, in connecting it with the life and death. Okay, but laser physics at the book side, the Einstein theory is not the same. It's huge different. But if you understand this concept, if you understand this fact, the laser goes into this way only. Okay, fine. Now, this is about the physics. Now we have to concentrate on production. This is the physics part. What is happening at atomic level, what is happening at electronic level. Now we have to instrument. Okay. There are 3 things: absorption, spontaneous emission, and stimulated emission. Absorption is nothing but when the energy is being absorbed, electrical energy being absorbed at valence band by the electron, that is known as absorption. Okay, fine. And in terms of laser, that procedure is known as pumping. In physics, that procedure is known as absorption. Stimulated emission and spontaneous emission I have explained to you. So these are the three terms only which governs the laser. Okay, now just look at here on the screen. What is exactly happening in absorption? This is your valence band, this is your conduction band. This is your lower state, this is your higher state. Okay, as we have delivered energy at this stage, this energy is there. Okay, at this stage, what will happen? This electron will get energized and it will jump from lower to higher. Clear? Now, spontaneous emission. What will happen? In spontaneous emission, we don't have given any other external factor. We don't have cause. So what will happen? The electron will complete its life. Okay, it will complete its life and it will come back and it will see the same energy which we have absorbed here. The same amount of energy has been released. But in case of a stimulated emission, what will happen? Okay, we will deliver one extra cause, that is population inversion in terms of laser. We have delivered a cause. Okay, so what will happen? This electron will come down as stimulated emission, but it will give the energy in this form. Why? One energy is which we have absorbed at the lower state, and another energy which has been created because of the population inversion. Okay, so two energy. So order of energy is higher. Order of energy is higher, and that energy is in the form of light. Okay, so you are able to differentiate between absorption, spontaneous emission, and stimulated emission. In the stimulated emission, the energy release is higher. That all you have to remember. Now, we have, these are the components we have in any laser tube. In any laser tube, these are the 6 components we have. These are the 6 components we have in any laser machine. Okay, what are these components are? First one is active medium. Active medium is nothing but I have told you the material which we are using for producing the laser. Okay, at balance band we have to have the materials which will out of which the electrons of which material will come from balance band to conduction band. That material is known as active medium in terms of laser, or sometimes it is known as lacing medium. Sometimes it is known as lacing medium. So lacing medium or active medium. Now the second is pumping mechanism. Pumping mechanism, I have told you, we are supplying the voltage to the valence band and the electron is going from valence band to conduction band. This is clear. Now leave this optical resonator, I will tell you what is that. Laser delivery system, leave this. Cooling, leaves this. Control, leaves this. So you know two things, about two components very well so far. Okay, now we will talk about the production. Can I have marker? Okay, fine. Give me one A4 sheet. A4 sheet.
Thank you.
Okay, now just stop looking at this, start looking at this. How the laser tubes are. This is my laser tube. Now what is there? There are two mirrors. There are two mirrors in the laser. One is this one, which is 100% reflective in nature. Which is 100% reflective in nature. And this is another mirror, which is 99% reflective, means it can 1% by 1% it can refract. Just be remember, because this works basically, this is what making the laser out of the laser tube. This 1% is only there. 100% and 99%. And the 1% which is present here is refracting, and this 1% is known as laser window. This 1% area is known as laser window. And these two mirrors are known as optical resonator. These two mirrors are known as optical resonator. Clear? These two mirrors are known as optical resonators. Fine. Now how the laser is being produced? Let's say the lacing medium is present here. The material from which I am going to create a laser, okay, that is inside the tube. Now what will happen? The pumping mechanism I have told you is voltage. The pumping mechanism would be voltage. As soon as I have started giving the voltage, what will happen? It will stimulate this lacing medium. Now you will not able to see this spontaneous emission, stimulated emission, that is physics. You cannot see at laser level. Okay, what is happening here? the elastic medium will get energized and it will jump to the conduction band and the same thing happens. Now you can see what when it coming down, it will the release of energy would be there. The release of energy would be there. See, now this window is, if this window is made up to allow 763 nanometer. Let's say this laser is made up for 763 nanometer. Now what will happen? No system is 100% accurate. No system is 100% accurate, but the output of the laser is 100% accurate. Okay, but inside the laser accuracy is not 100%. Now what will happen? These two photons are released. If let's say these are the 763 nanometer, they are at 763 nanometer, then what will happen? They will travel this side and they will get out from this window. But let's say one photon is released here, which is not at 763 nanometer, which is at 760 nanometer. Which is at 760 nanometer. What will happen? This will, instead of going to this way, it will go into this way. And it will hit the 100% mirror surface. Now 100% mirror surface will do what? It will reflect it back. Now when it's try